Bismillahirrahmanirrahim. Dear students, grade 12, and this is lecture number 57, and we are talking about the oxidation reactions of aldehydes. Lecture 57, grade 12 to number 19, and the reactions of oxidation of aldehydes. So when we are talking about the oxidation of aldehydes, we use the oxidizing agent. Oxidizing agents, mild oxidizing agents. Mild oxidizing agents like Tolerance reagent, Fallens solution. These are the mild oxidizing agents. Bendit solution, easily oxidized aldehydes to carboxylic acids. These oxidizing agents, tolerance reagent, Fallens solution, Bendit solutions, and also potassium dichromate and concentrated sulfuric acid, potassium permanganate, concentrated sulfuric acid, and dilute nitric acid also. These are mostly used for the oxidation of aldehydes to form a carboxylic acid. That's right, formaldehyde, actually they give nascent oxygen. This is the nascent oxygen in presence of any one of them, potassium dichromate solution and concentrated sulfuric acid with the dilute nitric acid. So formaldehyde is going to be oxidized to give formic acid. This is the formic acid. Acetaldehyde, acetaldehyde is going to be oxidized to give acetic acid. So these are the reactions of oxidation of aldehydes by using tolerance reagent, Fallens solution, Bendit solution, potassium dichromate, concentrated sulfuric acid, potassium permanganate, concentrated solution, sulfuric acid with the dilute nitric acid. These are the mild oxidizing agents to oxidize aldehyde into carboxylic acid. Now when you are going to oxidize ketones are only oxidized by strong oxidizing agents, not mild oxidizing agents, strong. Ketones are not aldehydes, ketones now. Oxidation of ketones. So we use strong oxidizing agents like concentrated nitric acid. We don't use dilute nitric acid. Potassium dichromate, concentrated nitric acid, potassium permanganate, concentrated sulfuric acid with concentrated nitric acid. Then ketones are going to be oxidized. We will not use mild oxidizing agents for the oxidation of ketones. So dear students, ketones are only oxidized by strong oxidizing agents such as potassium dichromate, sulfuric acid, potassium permanganate, sulfuric acid is a concentrated nitric acid. Now here the important thing you have to understand, the carbon atom joined to smaller number of hydrogen atom. In the ketone, maybe similar ketones, maybe dissimilar ketones. So the carbon atom joined to smaller number of hydrogen atom is oxidized first. This is one thing. This is when the ketone is unsymmetrical. When the ketone is symmetrical, both sides same number of carbon atoms. In case of symmetrical ketones, only one carbon atom adjacent to carbonyl group is oxidized. Only one carbon atom adjacent to the carbonyl group is oxidized and mixture of 2 carboxylic acid is always obtained. So here you can see the condition. This is a symmetrical. This ketone is a symmetrical acetone. Propanone, both same number of hydrogen atom attached. So in the presence of these conditions, we use a strong oxidizing agent, potassium dichromate, concentrated sulfuric acid with concentrated nitric acid. So in the case of symmetrical ketones, only one carbon atom adjacent to carbon is going to be oxidized. So this carbon is going to be oxidized, or this carbon is going to be oxidized. That is why you will get CH3, C double bond O, and when you get this one, you want to get a carboxylic acid, means OH. So CH3COH means CH3CO, hydrogen from here, and 3 nascent oxygen are going to be used here. Let me write here. Then like this. So this is going to be oxidized, CH3CO, and oxygen from here and hydrogen from here. One oxygen from here, one hydrogen from here. To make OH group, you will get a acetic acid plus HCOH. This is the formic acid. Acetic acid and formic acid are going to be produced here. So you can see that remaining two oxygen atoms are here and two hydrogen with the carbon. So one hydrogen will come here and this oxygen make a carbonyl group and second oxygen react with the hydrogen to make a formic acid. So you will get acetic acid and formic acids. In a symmetrical ketones, only one carbon atom adjacent to carbonyl group is oxidized and a mixture of two carboxylic acid form. One is called ethanoic acid, acetic acid, and other is formed formic acid or methanoic acid, formic acid or methanoic acid. Now this is about the symmetrical ketones. In the case of unsymmetrical ketones, just like butanone, butanone. This is the unsymmetrical because this carbon contains 3 hydrogen atoms, this carbon contains 2 hydrogen atoms. This is the symmetrical and this is the unsymmetrical. So in case of unsymmetrical ketones, the carbon atom joined to smaller number of carbon atom is provincially oxidized and the carbonyl group remains with a smaller alkyl group. However, in the case of unsymmetrical ketones, the carbon atom joined to smaller number of hydrogen atom means you can see CH2. This carbon atom CH2, 2 hydrogen atoms, is provincially oxidized. So this is going to be oxidized to make a one carboxylic acid functional group, and the carbonyl group remains, CH3CO remain with a smaller alkyl group, and then another carboxylic acid functional group is going to be formed here. So these are the nascent oxygens in presence of potassium dichromate, sulfuric acid, concentrated nitric acid, strong. So this is going to be separated CH3, C double bond O. So one hydrogen from the smaller number of carbon atom, one hydrogen and one oxygen from here. So CH3 same, carbonyl group he says same, and oxygen from the nascent and hydrogen from the here to make OH. So this is the one carboxylic acid functional group. Second, CH3 the same, and there is a carbon here and 2 oxygen are here, one oxygen to make OH and other oxygen to make a carbonyl group. So you will get another carboxylic acid group. So you will get 2 molecules of ethanoic acid, 2 molecules of ethanoic acid. So again I am telling you, if we have a symmetrical ketones, only one carbon atom adjacent to carbon group is oxidized and you will get mixture of 2 different carboxylic acid. One is acetic acid and other is a formic acid, symmetrical ketones. In the case of unsymmetrical ketones, means 2-butanone, so the condition is that the carbon atom joined to the smaller number of hydrogen atom is preferentially oxidized. This is going to be oxidized. And the carbonyl group remains with the smaller alkyl group. So dear students, these are the oxidation reactions of aldehydes and ketones to make a carboxylic acid. So review is that aldehydes are going to be oxidized. We call it catalytic oxidation. This process is called catalytic oxidation. You done in the alcohol chapter. Alcohols are going to be oxidized also the same conditions as aldehyde to make aldehydes and also carboxylic acids. So dear students, here we are going to end this chapter because of according to your reduced syllabus, oxidation reactions are here, 19.64 article we completed here. Last lecture I have told you about the haloform reaction, iodoform reaction, how iodoform is going to be formed. Then acid catalyzed nucleophilic addition reactions. I told you journal 2, 4, D and pH. So please go through this chapter. According to the reduced syllabus, you have to prepare for this one. Now I am going to start at chapter number 20, carboxylic acid and functional derivatives. This is the last chapter for the organic chemistry. This is a very important one again. So you know the pattern of the paper. Section B contains chapter number 13, 14. Then from 21 to 24. 13, 14, 21, 22, 23, 24. 6 chapters. Section B. Section C from chapter number 15, 16, 17, 18, 19, 20. 6 chapters organic chemistry. Then D section is a mixed one. A section is objective type. So dear students, now I am going to start chapter number 20, carboxylic acid. Carboxylic acid and functional group derivatives. Means from the carboxylic acid, other functional groups are going to be derived. So, the functional group of carboxylic acid is, this is the functional group of carboxylic acid. We done the functional groups. It has 2 functional groups, carbonyl and hydroxyl. That's why we call BO. Carbo means carbonyl, oxalic means hydroxyl. So 2 groups are here. Dear students, what is organic acid? Organic acid, the acid which contains at least one carboxylic acid functional group is called organic acid. Organic acid, the acid which at least contains COOH group is called organic acid. So, nomenclature, the general formula for the carboxylic acid CnH2n plus 1 COOH carboxylic acid functional group. So general names we have just like formic acid, formica, ants, it's present in ants. In IUPAC, methanoic acid, acetic acid, acetium, it is present in the vinegar, that's why we call it acetic acid. Butyric acid, present in butter, Barbara. So that's why these are the common names we give for the acids here. So if there are 4 carbon atoms, we call butanoic acid, formic acid, methanoic acid, acetic acid, ethanoic acid, propionic acid, propanoic acid, and butyric acid, butanoic acid, isobutyric acid, 2-methyl propanoic acid, tertiary methyl acetic acid. Trimethyl acetic acid. 1, 2, 3. Then this is the acetic acid COOH, or 1, 2, 3, 2, 2 dimethyl, 2, 2 dimethyl propanoic acid, 2, 4 dimethyl propanoic acid. So these are the names, and there is another one, pentanoic acid is called, 2, 3, 4. This is a pentanoic acid and valeric acid. This is a N-valeric acid. Pentanoic acid is called valeric acid. Now students, if the carboxylic acid contains only one functional group, one functional group, they are called mono. And if there are more than one functional groups are there, so we call it poly, many, di, just like oxalic acid. Just like oxalic acid, H2C2O4. Oxalic acid, or ethane darbic acid. So these are the important, you have to remember: oxalic acid, ethane dioic acid, propane dioic acid, malonic acid. Please remember these names. Propane dioic acid, you just increase one carbon here. If I put one carbon here, then this is called a malonic acid. So you have to increase one carbon more. Propane dioic acid, malonic acid. Butane dioic acid, succinic acid. Butane dioic acid, 2 carbon more. You you add like this one carbon, this is the allocated and this if you want this one. But if you add 2 like this one, 1, 2, 3, 4, this 1,4-diglutanoic acid. So this is a succinic acid. Succinic acid. Then 1,5-pentanedioic acid, glutaric acid, hexene-dioic acid, adipic acid. And if there is a benzene ring, this is the benzoic acid. Benzoic acid. If two functional groups, if we put another functional group COOH, which we call phthalic acid, 1,2-benzene dioic acid, phthalic acid, dicarboxylic acid. So these are the carboxylic acid which contain high number of carbon atoms in the 2-carboxylic acid functional group. Must remember these. Oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid, benzoic acid, phthalic acids. So must remember their names. Physical properties, dear students, highly polar in nature. There is a carbonyl group and there is a hydroxyl group, highly polar in nature due to the electronegativity difference. So high melting point, boiling point, analogous to alcohols, a high solubility in the water, hydrogen bonded dimers in the gas phase. So this is the dimer I am going to draw the structure. So dimer is here. This is one alkyl group CH3 may be what will be the number of carbon atoms. This is the carbonyl group ketone. This is the carbonyl group ketone. So it is going to be attacked hydrogen bonding with another functional group carbon. There is another functional group of the carboxylic acid. And this is the OH of the carboxylic acid, and it is going to be formation of bond with the ketone group of the carboxylic acid. So this is a dimer. Hydrogen bonds. Hydrogen bonding. Hydrogen. There is a hydrogen bonding between the oxygen and hydrogen. So in the presence of 2-carboxylic acid. So dear students, this is the nomenclature. So physical properties I told you. Then inshallah we start the structure and the acidity of the carboxylic acids. So here we stop the lecture. Thank you very much.